All right, the poll is up. We can begin the lesson with some question and answer. A poll isn't exactly a question and answer like a science or English or a math. A poll is to get some responses and to see how many of you choose a certain response. That's a poll. So that's different from having an exam. So this is a poll. If you have not tried this before, I welcome you to try it. So you will know how many people are in the class and how many people are actually writing down their answers or clicking their answers. 4 out of 11 people have entered their answers already. The rest, slowly. Good. More people have responded, at least half the class, 7, 8, 9. See, some of you just getting the hang of it. Just to click a yes and no also takes so long. And how are you going to answer science questions that require you to write more? Come on, fast. All right, shall we close the poll? Still people are entering the answers. Wow, good. I'll actually share with you the poll. You can't see what other people are saying until I share the poll with you. So those of you who have already answered, thank you, and we will eagerly await the start of this very first science Sec 1, Sec 2 lesson. I have not seen you guys online before. I've only been attending to my P3, P4, P5, P6, and of course I have my regular fans who come and join me for every lesson. You are here too. Okay, you can raise your hand if you are been attending my other lessons, have attended my other lessons before. And of course, you have watched my videos on the website 88 Tuition. So you have seen me and I'm familiar. So let's end the poll right here. We are done and I can share the results so that all of you can see how a poll looks like and how I can share the results with you. Okay, now you can see the results. Okay, so I've seen at least 10 lessons on 88 Tuition. It can be any subject. Yes, many of you can see how many people have responded with a yes. It's 83% of the class here. So you get to know your friends better. All of you are familiar with 88 Tuition and you're familiar with me. So not something like, oh, I've never seen this guy before. Where is he coming from? Okay, you know how I teach, what's my style, how I go through a class, but that's recorded. Now I'm live here, right here. If it's going to rain at your place, it's going to rain at my place. That's what life is all about. Okay. Okay. How does the second question affect anything? Okay, I have done the topic of elements. Today, we know we are going to do elements. If you have not done it in school, it will affect you because you do not know what's happening. It's okay. The purpose is here to learn, so you learn from the topic as well. Then, if you want to learn again and again, then you go for the recorded lessons where I cover elements and then I cover what you call compounds and mixtures that goes on the whole syllabus of your Sec 1 and Sec 2 textbooks actually already on the website. You know that? Those who have not tried it, try it. That means you can just pick on the lesson that your teacher is teaching in school and straight away revise it on our website. That means everything is on demand. You can click because different schools do different topics. And that's exactly why you have students here who have not done elements in school because your teacher has not decided to do it yet. You'll be doing it sometime later. Okay, done. Okay, I hope all of you can see the slide screen right now where we talk about elements. So you can see I've actually shared with you a very nice picture, blue screen. Okay, if you want to chat with me, you can chat with me. I will see your responses because I need your participations as well. So if you are typing your answers, you can type to me at any time during the lesson. Don't have to wait for me to ask you. Just type in whatever you want to say and I will pick up on it and even discuss it. I may even allow you to speak, so I may unmute you and so on and so forth. So that's the gist of the progression for today's lesson. So let's start. Elements. What is elements? Okay, we have some friends who do not know what elements are. So we have to say what the elements are. They are the basic building blocks of matter. So I'm going to write it down here. Just to put that on record to say that, you know, basic building blocks. So that's why you see a lot of blocks here of matter. Matter is anything that has what? Occupies space and has volume, and has mass. All right. There you go. Basic building blocks of matter. Okay, as we go through the lesson, you will find out what the elements are in detail. And let me assure you, if you go to the ADA Tuition website, I have the introduction to elements, which will benefit you greatly. So I suggest those of you who have not done it in school, after today or tomorrow, as soon as you can find time, go and click on the elements lesson on the website, and you'll find a more basic description of where these elements are actually fundamentally starting from. Otherwise, I need to go a little bit faster than that because, like I said, you have two options, right? You have the recorded version on the website, which you can go and catch up, or you come to the live lesson, we actually do more questions and more in detail, where you actually see me live going through the questions. So if you know where these elements are found, so let's look at some basic questions which actually sometimes can be funny. So watch out for this funny part. So I asked my student, where are elements found? The correct answer, it should be everywhere. Okay, even in the air, not only on the earth, but even in the air, even in outer space, you have elements. Okay, oxygen, nitrogen, every single thing is an element, so it's everywhere. You know what is the okay, maybe correct, but not so correct answer? You know what my student said? Guess what? Where are elements found? He said, they're found on the periodic table, teacher. Yes, they're found on the periodic table. It's a classification of all the elements found everywhere. Because elements are found everywhere, so you put them in a table, and there are so many of them. So you put them in a table and you call it a periodic table. And that's where elements are classified. So the periodic table is just a classification table done by human beings. Classification table done by human beings to make the study of these elements easier. Okay, but it doesn't mean elements are found on the periodic table. It means it can't be found on a piece of paper. Okay, these elements are found all around us. They are scientific building blocks of matter, like I said. So examples are, like I said, in gaseous state, you can find oxygen, you can find nitrogen, you can find helium, hydrogen, you can find metals like sodium, aluminum, everything that's around you is an element. It's just that, do you know the name of the element? Because sometimes it's not straightforward. It can be a scientific name. So you've got to be a bit careful about the names. So that's why you need the periodic table. Periodic table, right? You do not like to write the full name. Sometimes you have the full name. So if you look at the slide now, I'm going to circle the full name. The copper is the full name, the English name. Okay. But Cu is the symbol, which is easier to fit into the periodic table. Otherwise, if we start writing full names, we can't fit everything into the table. So therefore, we use symbols. And to characterize these symbols, we have further some numbers, which are called the atomic number and the mass number. Mass, you obviously know already. Usually how heavy are you, Mr. Let's see, I got Victoria. How heavy are you? No, I don't ask you how heavy are you. Okay. Roughly, I know, okay. My weight is my mass, my weight. Have you ever done mass and weight before? Yes, you have done in primary school. Secondary one, yes. What is the difference between mass and weight? Okay, that's for another day, but we need to know what is mass over here, which is usually in kg. So my mass is 65 kg. So let's forget about weight, since weight is for another day. Okay, weight is, you just have to wait, okay. All right, mass is 65 kg. So that's what makes me. My arms, my hands, my bones, all of them together weigh 65 kg when I stand on the weighing machine. But the mass of this element, okay, remember the fundamental building block, how heavy it is, will also give its characteristics. Okay, so therefore, this copper is 63.55 in mass, atomic mass, and the next one beside it, tellurium, is 127.60 in mass, which means it's double heavy. Okay, so can you imagine, we have all human beings, right? All of us are the same, right? We are made of the same skin, same eyes, I think, basically same lungs, same type. I mean, the composition of the cells and all is the same, but we weigh different because of what we are comprised of, we eat more and so on. So the student beside me or the friend beside me is heavier. So therefore, this table consists of everything, but they have different masses. And atomic number will refer to the number of protons. Okay, so I have to highlight one more circle here. Protons inside that element. So what is a proton? Okay, we carry on. So we know roughly what we are getting into. So let's look at the periodic table. Okay, that was a big picture of copper and tellurium, right? Now let's put everything inside one periodic table, and this is what it looks like. Okay, I know 70% of you have seen it before. I know what I'm talking about. 30% of you, time to catch up. You need to have more reading after this class. Okay, so we have got oxygen. Okay, so where do we start? Okay, where do we start? Let's read first. Elements are classified according to their properties, physical states at room temperature, and whether they are metal or non-metals in the periodic table. So obviously, okay, so this is the way we classify. Human beings have got all these elements all put on my table, just like if you have a lot of books on your table. You have science, math, you have revision books, you have textbooks, you have notebooks. What do you do to them? The first thing you do as a human being, you'll be like, let me use my brain. Let me think. How can I classify this in a way that it will help me? And it'll be neat and tidy, right? So you either categorize it by subjects. So you put all the science subjects in one box and all the math in one box. Or you categorize it using all the assessment books in one box and all the notebooks in another box. So you actually can have a mix of subjects because you actually have all the assessment books in one box. Depends on you. Depends on how you want to use it, and it helps you the most. So that's why this table helps us a lot because of the classification. And what is the classification based on? Based on the physical states. Are they liquids? Are they liquids or solids or gases? Okay, their properties, the temperature, and whether they are metals and non-metals. So these are the main things that you can actually see on the periodic table. So how they are divided? Okay, where do we start? So like I said just now, where do we start? Let's take this circle. What is this called? H. And then what's this called? HE. And see the number that is on the top right-hand corner or top left-hand corner. That's it. From the previous slide, we learned that that top is called the atomic number, which is the number of proton inside it. That means this element has one proton. The second one has two protons. The third one has three protons, so on. So all of them have the characteristic number. So we place them in order. So that will make classification very easy. Let's identify this guy. He's called hydrogen. Oh, so I guess the smallest, simplest element in the world must be hydrogen because he has only one proton. The second guy is called helium. He has got two protons. And we build on and on and on and on, and we put all of them together. And you can see the numbers increase across the board with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like there isn't one element that is a duplicate. There's no one element that has the same number as the other, which means that the characteristic number of the atomic number, which is the proton number, will tell us what it is or who he is or what he exactly is. Okay. So for oxygen, let's look for oxygen. Can you see? I've written down oxygen here. Can you all find oxygen for me? The symbol for oxygen is just O. So what is the atomic number of oxygen? If you can find for me oxygen. Okay, those who are very familiar with periodic tables, right? You can find oxygen very fast. Charmaine, John Paul, thank you. Doreen, Jethro, Shivani, thank you. All of you gave me the answer 8. You can find because it's highlighted there. Oh my God, it's highlighted already. It's 8. So how many protons does it have? 8 protons. Okay. And the funny thing is they also have 8 electrons. Okay, if they are balanced. Okay, that is also important. And then how many neutrons do they have? Now this is another question. So in elements, right, you will have proton number, electron number, neutron number. These are the only 3 components of an atom. Okay, so that's atomic structure. Okay, it's not included in today's lesson, but I will get to there one day where I will talk to you about the protons, neutrons, and electrons. I know some of you are advanced already, so you know this. So that's why I'm going to say let's leave this proton and all this out, but we just talk about elements and their classification today. Leave the atomic structure to another day. But if you are interested, like I said, go to my website. You already can study atomic structure immediately if you want. So the properties, okay, we're going to dissect the properties further. Okay, if they are going to be classified according to their physical properties, okay, okay, guys, I'm back. Sorry, that was my little baby son who was trying to get at my attention. I know you guys are more important to me and need my attention right now, right? So I've given him time off. Okay. All right, let's continue. So I'm sure you read the slide while I was away for a brief moment. Okay, classifying elements would mean to classify them according to the properties, physical states at room temperature, and whether they are metal or non-metals in the periodic table. So states at room temperature. Okay, so what are they? Are they liquids, solids, or gases? That's the important thing that you need to take note of. And that's how we're going to be on the table. So that's, oh, at room temperature means roughly around 28 degrees Celsius to even 32 degrees Celsius. That's the room temperature where? In Singapore only. Please do not think it's the room temperature in Australia. In Australia, it may be different. In England, it's different. Right at this point of time, room temperatures are all different across the world. But in Singapore, since we study here, we do exams here, we tell you the room temperature must be ranging around here. If it's anything not from this range, then something's wrong. Okay, we are a tropical country with temperatures that are ranging in the 28 to 32 all year round. Okay, so liquids, gases, so and solids. Okay, examples: mercury, bromine. So you have a periodic table full of liquids, gases, and solids at room temperature. So it's important to note that we are taking these states at room temperature. If we take the states at any other temperature, then the state will change. Then it's not a good classification technique because you are changing the temperature all the time. So you need to have a classification tool, a code to say, okay, I'm going to classify them in their states at room temperature, which is 28 to 32. So these are some examples. We go on, and then we have examples of metals and non-metals in the periodic table. They are also separated in a left and right side of the periodic table, which we'll look at later when I show you the full periodic table. Physical appearance at room temperature, metals and non-metals. Okay, this is earlier is what? Solid, liquid, gas. Now is what? Metal and non-metals. So metals are usually solids, yes. Sometimes can be liquid or not? Can. There, except mercury is a liquid. Okay. Shiny? Yes, most of the time shiny. So these are the properties, physical appearance. And then non-metals are usually dull and what? They can be all three states. What is malleability and ductility? This is another thing that is required in this topic to know what these two terms mean. In order to know, by now your teacher should have mentioned malleability and ductility already. But it is a difficult concept, okay? Because even after I learned it many times, sometimes I get confused. How come? Because they are very closely related. So what is the difference, okay? Let's read it together. Or if you want, Victoria, do you want to read it for me, Victoria? If you can.
It's okay. You can go ahead and read it.
Okay, let's read it together, Victoria. Malleability refers to the ability to be beaten into shape without breaking. Okay. Can? Ductility refers to the ability to be drawn into wires. Now, these are the key words in terms of malleability and ductility. So M stands for beaten into shape. So, you know, metals can be beaten into shapes like this, or shapes like this. Okay. Metals if they can be beaten into different shapes, that is malleability. If they can be made into very thin lines or wires, that's called ductility. So how ductile a metal is will mean how much can you thin it down to become like a wire. Okay, so that's ductility. Now, each metal has a different ability to perform this role of malleability and ductility. So some can become wires very easily, some very difficult. So you cannot, it's not ductile at all. That's all. So if you say this metal is not ductile, what does it mean? It means it cannot be pulled into wires. It's very, very stubborn, very thick, cannot do anything. But maybe it can be shaped into different shapes, so it's malleable. So is it malleable? Yes. Is it ductile? No, and so on and so forth. So you need to know the difference between the two, just in case this is tested. Oh, it will be tested. What else? Melting point, boiling point of metals. Usually, metals have very high boiling points and melting points, and low for the non-metals. This one also another straightforward property of metals. Density, usually very high, very low for non-metals. What else? Conductivity, metals conduct heat very well and electricity very well. How many properties? 1, 2, 3, 4, 5 properties that you need to be aware of when you talk about elements, which are metals versus non-metals. Remember this, we may ask you this too. What are the differences between metals and non-metals? Then you pick up the differences. Classifying elements, back to this. Okay, now, since we found out that elements can be solid, liquid, gas, or can be metals, non-metals, that's all we need to do and put them in here. So let's look now. I've actually colored it in, color-coded. So tell me where the metals are. What color are the metals? What color are the non-metals? Type in your answer right now. Color of metals are thank you, Jethro, Shamin. I only got 2. How about the rest of you? Okay, you are shy to talk, no problem. You can actually type your answer so that you participate actively and you learn something. Otherwise, you can be better off watching the TV right now, right? Metals are the blue parts. So many metals. Wow. And then this part here is a dividing line. Can you see? It's funny enough that we need a step. So actually the world is very kind to us. After we classify them, we find that there's a structure, there's a beauty, there's a line that makes everything look so nice. That this line divides the non-metal. So what happens is what's this? Okay, non-metals. Fine. Now I'm going to leave you with one question unanswered that is going to leave you to go and find out the answer. If blues is, there's some metals that are green as well. Okay, so people coloring it for some reason. Why is it green and why is it red? Okay, I'll let you find this out from your textbook or wherever you can have your resources. Why red? What are red and what are green? Maybe the green is the one, the special one. Why are they special? Okay, I'll give you a clue already. There are some special ones. Okay, so what are greens? Maybe you can type to me if you know the answer. Of course, you're not going to be able to share this answer with everyone because I'm going to hide this answer till next week. Next week, I will reveal to you what this green color, why do we color it green? The rest, red, I think is quite obvious. Red is because it's non-metals. But green, they want to specifically mention this green because they have some properties. Okay, Shivani, thanks for your answer. I think you're correct. Okay, so we are somewhere, okay, where I leave it to you to go and research and tell me so you have some homework to do. Maybe you will find out in the questions, okay? So in the periodic table, elements are arranged according to the proton numbers. Remember, we started with 1, 2, 3, and so on. 1 is hydrogen. 2 is helium. What is 3? I always remember first 2 because both are H and hydrogen. Third one, oh, I need to go to the periodic table. Don't expect me, even as a science teacher, to remember or memorize this whole periodic table. I don't need to, right? Because I have the periodic table. Do you know that in the exams we give it to you as well? We don't expect you to remember. Okay, we give you the periodic table whenever you need to use it. So you just have to look at the numbers and identify the elements from the table. What are periods and what are columns? That's what we're going to do right now. What are periods and what are columns? So let's highlight this period. A period is anything that is across in a row. You know, you say you sit in a row or a column in class. You know, your all the students in row 1, can you submit your papers right now? Actually, row doesn't mean this way, not from the front to the back. That is a column. A row is left to right. Okay, so this is left to right, which is also a row in layman's term. In the periodic table, we call it a period. Let's look at group is a column. So in the layman's term, we call it a column. You know, we all sit like this in the classroom as well, right? So you must know you are in, that's why we call it group 1, group 2, group 3. We don't say, I know all the time in the class, we say row 1, row 2, row 1, you can go for a recess first. But actually, it shouldn't be row 1. You should correct your teacher and say, sure, actually, it should be column 1. Column 1 can go for recess right now. So column is from front to back, row is from left to right. So when your teacher says row, it's actually all the front people can go now. Okay, so be careful on what is row, what is column, because it's very important in math, in science, and even in English. But in science, in this case, we need to change the word row and column to period and group. Okay, so this is a period, this is a group. Now what happens is period start with a metal on the left because it's all blue, right? Then when it goes to the right, it becomes non-metal, right? So that is one period. So what period is this one? Is it 3? This is period 1, this is period 2, this is period 3, this is period 4. So this is period 4. So if I say, guys, can you find for me an element that is in period 4, group 2? Oh, then I need to know what is group, right? So this is group 1, group 2. This is group 3. This whole thing is group 3. Okay, this is group 0. This is group 7, 6, 5, 4. So the whole thing is group 3. That's another amazing thing. So this whole side is group 3. Okay, so take note of that because it's so big. We classify everything in the middle as group 3. But group 1 and group 2 are very important. That's why they stay separate. They don't go into group 3. And then group 6, group 7, group 5 are also very important. But group 3 is a broad group. That's all. Okay, so how many periods are there? 7. How many groups are there? 8 or can we call this 8? Sometimes we call this group 8, sometimes we call it group 0. It doesn't matter because there are some chemical reasons for that. When you learn chemistry, you will know. Okay, doesn't matter for now. All right, so groups and elements. Groups are vertical columns that have similar chemical properties. So let's look at this. Group 2. And usually, even though I write group 1, group 2, right? Usually we write in Roman numerals. Okay, that's another important thing. So that do you know your Roman numerals? Do you know your Roman numerals? I should write it above here. 3, 4, 5, 6, 7, 8. Okay, I know my Roman numerals. Okay, so the group 2, let's focus on group 2. It has BE, MG symbols that all of these elements have similar chemical properties. Okay, take note of that. Then in group 1, all of these have similar chemical properties. So that's the interesting part of this classification. So you need to realize you have period, you have group, you have columns and rows, which are called groups and periods, and then you have to decide for yourself which one do you think will act similarly. For example, if I say all of you, can you all of you stay on group 1? So this one is primary 1, say let's say. This one is primary 2. So all the primary 2 have the similar characteristics, right? Because all of you are 8 years old. All of you are around 140 cm in height. Then all the primary ones, oh, all of them are 7 years old. They are all about 130 cm in height. And they all just have new school uniform. They all are very blurred. They don't know what to do in school. They all don't know how to buy food in canteen. See, that's the common characteristic of the whole group. So that's how we talk about grouping. So elements at the top are usually denser than those at the bottom. Means denser means something to do with mass. Okay, elements at the bottom always are bigger mass numbers, and therefore they are denser because of they are bigger and bigger, getting bigger and bigger. Because, like you know, at the start, hydrogen has only one proton, and then 2 proton, 3 proton, until 100 plus protons. So they are becoming bigger and bigger and bigger. So therefore, they are denser at the bottom. At the top, they are less dense. What is density? Also, we will learn in the mass, weight, and density chapter. Again, this is something to do with what? Floating, remember? If an object is dense or less dense, it will sink or float. Okay, I will leave it at that for now. Okay, these are the questions that I passed to you over the weekend for you to try. The feedback that I get is you guys don't try it, because class you don't try it. Okay, that's number one. Number two, you're asking me, where do I get these questions? Where are you getting these questions? I thought I just come for the live class, you're going through these questions. You mean I got these questions already? Yes, you did. Okay, when you go to the website and click on join class, you see it in the blue button. Next to the blue button, you see a red button which says class prerequisite. Prerequisite means you can download the questions to try, and then these questions will be discussed by the teacher in class. So did you download them? No. Why? Because you don't know what to do. Okay, now you know. So next week, make sure you download the questions and you will have seen these questions appear. And if you have done it, then you will have been well prepared. Okay? Never mind. That's why today is the first lesson. I'm meeting you after such a long time being on the recorded version live. Next week, we go even faster by you having done your homework beforehand. Right now, elements can be classified into, let's do the questions. You can do it straight on the spot, actually. Elements can be classified into, we just covered this in the last half an hour. So if you learn something, tell me what the answer is. You can just type to me, chat. Okay. Can be classified into metals and non-metal. Yes, I did that. No, I didn't do this. Okay, there must be only one answer. What is this chemical formulae? Symbols, can they be classified into symbols? All of them have symbols, so they can't be classified as symbols, okay? All of them have symbols. But are all of them metals? No. Are all of them non-metals? No. So they are classified as metals and non-metals, left and right, blue and red. You understand what we're doing right now. Okay, so that's A. So very easy. Now, second question. Okay, I just assume that 80% didn't do this question before. So I'm going to give you, every question I'm going to give you 30 seconds to actually look at it and do. And I'm going to keep quiet. And you just type your answer. So I will get to see your answer. Good. All of you understood the first part? This element could be anywhere in the periodic table, could be anywhere. But in order to know where it is, you need to know its properties. The property, whether it's a metal or a non-metal. Remember this dividing line? Remember? So this side is all metals, right? So only B is a metal, you know. The others seem to be on the other side. All three of them are non-metals. Am I right? This is the first thing. So they are given the description: high melting point, high density, good conductor electricity. All of them sound like it's a metal. And therefore, I can zoom in and say, hey, I think B is the most appropriate material that you can't really say for sure, because they are on the other side, and they do not have good conductivity of electricity and high density and high melting point. Only metals do, because we did that in the differences earlier. So let's try again. One more. Another 30 seconds. This one only needs 10 seconds. Right? What am I doing? I'm writing the group number. Group number 1, group number 2, group number 3, group number 4. Which one of these elements belong in the same group? There are none of them that are on top and bottom except J and K, because they belong in group 2. Understand? So J and K belong to the same group. Again, 10-second question, right? That one easy. Okay, so which one then belong to the same period? You can't look up and down anymore. You have to look left and right. Left and right, where anything in the same period? There are 2. Okay, J and L belong to the same period, period number 2. Right? Then, what's the other one? K and M also belong in the same period. So you've got to look for JL or KM. But KM not there. So thankfully, we just choose B. Okay, you may say, hey, J and L also. K and M also. Yeah, K and M also. Yes, you're right. But it's not in the options. It's not in the MCQ option. So it's okay. So thankfully, it's helped us out. Okay, it's not the option. Okay, another 10 seconds to do this one. What's the chemical symbol for potassium? A is the answer, B is the answer, C is the answer. Now, this looks like it may be the answer. This also looks like it may be the answer. Okay, let's look at P. What is P? P is actually phosphorus. What is PO? I don't know if there's one like that. It's just to confuse you. Okay, so actually potassium is K. Why do we have K? Why do we have K? What is km? Some people's km is actually kilometer. There's no km in the, again, nonsense answer this one. Okay. So K is because of the Greek name for potassium. Okay, we use some Greek names because there are lots of P's and there's lots of elements that use P. So not everything can be given P. Okay, for example, sodium, which is very common. Okay, we don't give it S because there's another element called sulfur. Then both of them fight. Hey, sulfur also one S, sodium also one S. Then how? So sulfur we give it S, then sodium we give it Na, which is also the Greek name for sodium. So we just, yeah, some of you are very good already, Doreen and all that. You know your Greek alphabets and names of elements very well. So that's where the difficulty starts, okay, where the difficulty starts, because in English it's potassium, but in Greek is K. What's K? You can go and find out what's K. In sodium, it's in English, and the chemical symbol is Na. What's Na? You can go and find out what's Na. Because if I start teaching you Greek, then you'll have a Greek lesson here. You don't need to, but some of the common ones, okay, so you need to know sodium very well, you need to know potassium very well, because they all come from group 1, group 2. So group 1 and group 2, we will always ask very often. Also, we will ask a lot of group 7 and group 8. We'll ask a lot. Okay, so if you can know all the symbols in group 1 and 2, at least the first 2, or okay, 2 periods or 3 periods, that's fine. So can you imagine I've just broken it down to How many? How many do you need to know now? For the purpose of exams, okay? 1, 2, 3, 9, 10. About 12 elements you need to know their names and their symbols by heart. Okay, so these are the ones that we'll pick often because we can't be unfair. We can't be unfair to you, right? Ask you to remember the whole periodic table. It's not fair. Okay, so define the term element. Element. An element is a pure substance. Okay, Charmaine, so I will have love for you to actually speak. If you want to speak, you can raise your hand. I will unmute you and you can say your answer out loud because she has typed for me the answer really quickly. So good. So I can read her answer for all of you. Okay. Element is a pure substance that cannot be broken down into any simplest substances by chemical methods. Okay, and they are also called basic building blocks of matter, which I said at the very start of this lesson. Doreen has said element is the basic building block of matter. That's all. So which one is right? Both are right, right? Element is the basic building block. Water, matter, not water. Element is a substance that cannot be broken down. Thank you, Charmaine. Very well done. Cannot be broken down into any more simpler substances. See the word simpler and cannot. All you have to remember is that cannot be broken down because it's already simple enough. It's the simplest thing that you can find in the world already put in the periodic table. So it's called an element, right? An element is the simplest thing. So you want to break further, cannot. You break further, you break aluminium further, you get aluminium. You break aluminium further, you get aluminium again. So that's why you cannot break it further. Whereas, for example, you can break steel. Steel is a composition is of iron and some other mixture of metal. So you break it down, you get iron. So that's an element. Steel is not an element, and hence steel is not put in the periodic table. You understand? So steel is just an amalgam of different metals, a mixture of metals, whereas iron is. So let's draw that. Steel, you can break it down. You can get like iron plus other metals, whichever it can be, compounds or elements. So this is an element. So you cannot break down element anymore, but still you can. So this is not an element. So this is the basic understanding. If you understand this, then you can write it down in your own words. Element is a substance that cannot be broken down anymore into any simpler substances by chemical methods. Sometimes this is also an important point. Okay, not by breaking by physical method, not like the breaking into. It's not a biscuit. Okay, you know there's a difference. Okay, you know this is a good example. A biscuit. A biscuit can be broken into two. That's physical. But can you imagine what you do to the biscuit when you dip it into your tea or coffee or hot water? It just dissolves, right? That's chemically changing it. Why? Because the biscuit is disappearing. Where is the biscuit gone? Hey, it's chemically changing into something else or just dissolving into the tea. Dissolving into the tea. So is dissolving a chemical or physical change? Dissolving is actually just a physical change. If you can still see the biscuits inside, but if you cannot see the biscuits inside, then something has happened to the biscuit. Magic. Okay. Good example to think about. Okay. State one characteristic of the elements in the same group and in the same period. Ooh, interesting. This is same group. This is same period. We discussed this already. Same group will have, remember, primary one, all of you will have very nice, tidy hair, new uniform. So what kind of characteristics will the same group have? They will have similar characteristics. It's on properties or characteristics. For same period, there are a few possible answers. Okay, the atom size gets larger. The proton numbers are increasing because as you go this way, remember, the proton number here is a small 3, here is 4, here is 5, here is 6, here is 7. So this is a characteristic of a period. The properties gradually change from those of metals to become non-metals to the right-hand side. That is also supposed to be understood by now. Yeah? Okay, same number of what? Is it same number of atoms? No. Increasing number of atoms. So it's increasing atomic number or proton number. Here you can say atomic number. Anything, both are the same. The atoms get larger. They get larger as the atoms grow because of the protons and electrons. Okay. Use the periodic table to answer this question. Name the element in group 2 and period 3 of the periodic table. Oops. You need the periodic table or you already know the answer? Calcium. Oh, how do you know? Group 2, period 3. How to find? Shall I go to the periodic table? Can I find the periodic table? No. Maybe I should have put a periodic table here. Okay. Since I don't have it and you might have it, or maybe I should just open up my science book and check. What book is Mr. Ali using? Can you recognize? Is there any periodic table? You can find periodic tables in all the science books. So I'm hoping to find one here. If I can't find, then too bad. Hey, come on, man. You didn't give periodic table. Oh, maybe I should go to the periodic table. Hey, but this is not a secondary book. This is primary school. Of course, don't have. Okay, so you guys can find periodic table and then for group 2. So how does that work? Like that, right? And then 1, 2, 3. This guy. What's the name of this guy? Is it magnesium? I hope so. I found it to be magnesium, so I write down magnesium. Okay. State whether this element, magnesium, is a metal or non-metal. Because it's on the left-hand side, is a metal. And suggest the chemical name of the compound formed when the element named in A reacts with oxygen. Okay, what is this? Let's write it down so that you all know. It seems too cheap if it's written in symbols. It's actually, how do you get it? Magnesium combined with oxygen. You don't get magnesium oxygen, you get magnesium oxide. Okay, so the symbol for that is Mg and O. Why? In the periodic table it says so. It says Mg. Oh, so this is Mg. Magnesium is not M, it's not Ma, it's Mg. Again, this forms one of the 12 to 20 elements that you need to know. Okay, why I say 20? Some of the students actually just say, oh, my teacher said I need to know 20 elements. Okay, let me tell you. 12 is good enough, but your teacher says 20 is so that you can know more. Maybe during class test, you want to test you 20, but usually in the national exams, we don't test you so many. And anyway, even if we test you, we give you the periodic table, right? We give you the periodic table. So you can actually have a look at it. Okay. A simplified periodic table is shown in the following diagram. Which section contain elements that conduct electricity? Oh, which sections? Is it only one section? Is it just A? Is it B also? Is it C also? Is it D also? Okay. Remember, where are the metals? Yes. What are these shaded? Metals. Remember that step-like line is here. So therefore, A, B, C, D are all metals. And therefore, if you write here metals, I'll write here wrong. Okay. You have to write A, B, C, D. Okay. A, B, C, and D. Okay. Good. Which section contain all the elements that are in the gaseous state at room temperature? Gaseous. Oh, looks like A, B, C, D all should be metals except mercury, remember? Okay, I mean should be solids. Okay, so you got solids. And then you got E, you got F, you got G. So one of these must be the answer, right? Which one has, which section contain all the elements that are in the gaseous state at room temperature? Room temperature. Okay, here you actually have a lot of solids. Here you actually have solids, liquids, gases. Maybe here you have some liquids as well. You can see as they go to the right, they are getting to become gases. Okay, so they are noble gases. They are all categorized under one group, and that is F and G. Okay, is it F and G? It's better to just put G, no F. Okay, no F. Okay, because F have a mixture of liquids also. So I'm going to just say G. F is wrong. Okay, elements X and Y are found in the same group A. Okay, let's do X and Y are found here. Element X reacts with oxygen. Oh, plus oxygen. Do you think element Y will react with oxygen? Will Y react with oxygen? Let's go. Yes or no? Do you think Y will? Because they are in the same group, they will have the same characteristic, they will have the same properties, so they will do the same things. Remember, they are all in primary one. So I ask you, you're all in primary three. Do you think you will take science as a subject? Yes. You're all in primary one. Do you think you'll take science as a subject? No, because all of you in the same group do the same things. So here, these guys in the same group will do the same thing. So if they react with oxygen, Y will also react with oxygen. Yes, it will. Okay, yes, since they have similar chemical properties. So all I want you to write is similar chemical properties. They will have similar chemical reactions as well. So that's what my reason why they will do the exact same thing. Element Z is a liquid at room temperature. It is found in group 7 of the periodic table. Identify this element. Okay. Now, this is a bit tricky. It requires your knowledge of the periodic table, which I have, and maybe you have, maybe some of you have. Let's take group 7 only. Okay. And we find out what's in group 7. Shall we? Okay, let's find out. I know there is this thing called bromine, and there's this thing called chlorine. What thing? Element. Okay, and this iodine. The funny thing about these three is, okay, they take up these three places. I don't know which place. I'm not going to tell you. If you look at the periodic table, you can tell. But the great distinguishing factor about these three is one is a solid, one is a liquid, and one is a gas at room temperature. I think so. So shall we find out which one is which? There you go. Group 7. Oh, there's even fluorine. So let's fill this table up together. As we fill up the table together, we will learn some things, okay? So fluorine is F, Cl, and bromine is Br, and iodine is I. So I filled up the first two columns for you. Now, we need to find out what state they are at room temperature. Okay, so room temperature, boiling point is minus 188. So minus 188, it already boil away as gas. So at room temperature, it is a gas. Okay, so fluorine is found floating around in the air as a gas. Chlorine is also a gas because by minus 34, it is already boiling. Whereas bromine is 58, so it's actually a liquid. Because at 30, so the room temperature is about what? Room temperature about 35, no, 20, 28, 32. At that temperature, it is liquid. Once it reaches 58, then it will start to boil, become a gas. So it is a liquid at room temperature. At what temperature? Maybe we can take it as 32 degrees Celsius, maybe. Okay, and since iodine will only melt at 114, that means at 32 degrees Celsius, it's still a solid. Okay, so I can write at 32 degrees just a number, or to be more accurate, I need to write what? Room temperature. Very clear? So now this is group 7. So let's redraw that group 7 again. 1, 2, 3, 4. This is group 7. And I don't want to write the full name, so I just write F, Cl, Br, and I. And at room temperature, this is a gas. This is a liquid. This is a liquid. This is a solid. Oops. This is a gas. Am I right? Based on their melting point and boiling point. So it is not only important to know what state they are in and memorize, oh, it's gas all the time, it's liquid all the time. It's not actually, it's depend on whether it's the room temperature or not, and depends on their properties of melting and boiling. So that's why I put this table so that you can learn how to distinguish whether their state is going to be liquid or solid or gas at any temperature by basing it on the numbers given on the data like this. Okay, so it's very important. So which element is a liquid at room temperature? There's only one, right? Let's go back and see. Yes, there's only one. Can you see? The rest are gas and solid. There's one that is liquid, that's bromine. So I write down bromine. State one element that is found in the same period as sodium. Oh no, where is sodium? Sodium is Na. So if you have the periodic table, you look for sodium, then you look across the board. Do you know that you can write as many answers as possible? Because, like I said, that's why we will give you the periodic table. So anything that is here, 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 all are correct answers. I'm not going to restrict the answer. Anything that is in the period of sodium is the correct answer. Okay, so there you go. Where is sodium? Where is sodium? Who can find sodium? What's the symbol of sodium? There you go, sodium. So what can the answer be? Mg, magnesium. What about the rest? Can it be? It's all far apart on the other side. Can it be those things as well? Yes, they are all in the same period, period 3. Okay, they are same period 3. So all of these can be answers. 1, 2, 3, 4, 5, 6, 7. Any one of these you write can. Why? Because in the exam you got the access to this periodic table. You take a look at it. You find sodium because you know sodium very well. You know it's called Na. And then you look across the period. You find A, Mg, Al, Si, Pe, Cl, all can. Okay. Some student may say, hey, no, you wrote wrongly. You wrote aluminium wrongly. You must write magnesium. Then that student doesn't know what's going on, right? He doesn't know that all of them are in the same period. Then you say, hey, no lah, you can write anything in the same period. You can write aluminium, you can write silicon, you can write phosphorus, you can write sulfur, chlorine, argon. Okay, all of them are correct. Okay, therefore I choose one. All right, so end of lesson. Well done today, because I wanted to start off with the small topic elements, but of course next week we will carry on the elements, atomic structure. We'll carry on with compounds and mixtures, which all come under chemical composition. So go through your textbook and read it thoroughly before you come. If you can't, then just do my questions before you come. Okay, go and click on the red button beside the join class, download the questions, do it before you come. That will help you a lot. And those of you who have not done this topic in class, then you have to read a bit more in advance to be able to catch up with us. So I've given you the guide on what we're doing next week, right? We're going to do compounds and mixtures, and maybe a little bit of atomic structure, or maybe the following week. For the next 2 weeks, we'll be doing this, okay, throughout the final week of circuit breaker already, right? We've got 10 more days before June 1st, and then we are all going back to school. Yes. So make use of the time, and I'll see you guys in lesson next week.